We're going to solve this system of equations using the substitution method today. And the first step is to isolate one of your variables. It's best to isolate the one variable that has a coefficient of 1 if there is one. That way you won't get any extra fractions. So I'm going to take this first equation, a plus 2b, a plus 2b equals 1, and I'm going to subtract 2b from both sides. That gives me a equals 1 minus 2b. This is what our book refers to as the revised equation. So what we're going to do is substitute the 1 minus 2b in place of the a in the second equation. Very important that you plug it into the equation that you did not start with. So I'm going to plug that 1 minus 2b right in here for the a, and then I'm going to get 5 times 1 minus 2b plus 3b equals negative 23. So that's the first part, substituting in. Now we have to solve this equation for b. So I'm just going to use my regular distributive property here. We get 5 minus 10b plus 3b equals negative 23. These negative 10b and 3b combine to make a negative 7b. So 5 minus 7b equals negative 23. Subtract 5 from both sides here. I get negative 7b equals negative 28. And then when I divide both sides by negative 7, I get b equals positive 4. So b equals positive 4 is part of my answer. And then I have to substitute that 4 back in. I can really substitute it back in anywhere in the original equation, solve for the a. Our book suggests that you take that and plug it back into the revised equation here for this b, and you would get your a, because it's already isolated, a little more quickly. A is equal to 1 minus 2 times 4, or 1 minus 8, or negative 7. So A is equal to negative 7, B is equal to positive 4. We will usually write our answer as an ordered pair in alphabetical order, so A comes before B, and that would be the solution to our system. Now we should check this, so here's your check step, and when you do the check step, don't forget to plug your A and your B back in for both equations, because it has to make both equations true at the same time. So into the first equation, negative 7 is going in for the A, 4 is going in for the B, so I want to see, does negative 7 plus 2 times 4 equal 1? Well, negative 7 plus 8 is equal to 1, so that checks. Then plugging into the second equation, the negative 7 in for A, the 4 in for B again, you should show 5 times negative 7 plus 3 times 4 should equal negative 23. That's negative 35 plus 12. Remember, when the signs are different, you're going to subtract them. 35 minus 12 is 23. Take the sign of the larger, negative 23 equals negative 23. So that checks. So we're done.